Hello everyone. Uh, Today we are going to solve a question from array. The question is present in InterviewBit platform. I will give the link of this question in the description box. The question name is Sum Contiguous Subarray, and this is asked in a lot of tech giants like Facebook, PayPal, Yahoo, Microsoft, LinkedIn, Amazon, and Goldman Sachs. Let's just read the question first. The question says that find the contiguous subarray within an array A of length n which has the largest sum. So we have to find a contiguous subarray which has the largest sum. The input format is the first argument is an integer array A. Okay, so we are given only an integer array, and AI can be from -1000 to +1000. The value of n is from 1 to 10 to the power 6. So let's look at the sample inputs here. So for 1, 2, 3, 4 minus 10, the maximum subarray is 1, 2, 3, 4, which has a sum of 10, right? And for this input, we have an output of 6. Okay. So let's just take this array. I'm taking this array and let's see how we can approach the problem. So I have taken this array here. So we have to, first of all, we have to find the maximum sum subarray, right? So what is the first thing that we can do, right? So each subarray in this array will be like each contiguous subarray will start from an index and will end in another index, right? So for example, this subarray is starting at this one index and will end at this index, for example 2, right? And if we can generate all the possible subarrays that can be possible from this array, and we can take all the sums and get maximum out of it, we can find the answer in that approach, right? So what we can do is we can take an index I, and I will point to the starting point of a subarray, and we can take another index which will be j. J will be pointing to the ending point of a subarray. So what we can do is for each I we can find all the possible j's. For example, let's start I from this 0th index. Okay, so I is present here, and we can iterate j through all over the array. So first j will be at the same position, which is at 0. So I is 0 and j is 0, right? So what will be the sum of that subarray? That will be -2, right? Next, if we take j from 0 to 1, so the subarray sum will be -2 plus 1, which will be -1. So we have a -2, we have a -1. Similarly, if we go take j from this first index to the last index, we will get all the sums, right? So all these sums will be of a subarray which is starting from index 0. Similarly, for each I which or for each starting index, we can find the sum of the subarray, and then the maximum of those sums will be our answer. So if I had to write the pseudocode for it, let's see how it will look. So we'll have a for loop for I. So I represent the starting index, and j we can start the ending index of the subarray from I2. You can take it towards the at the end of the subarray or end of the array, and then we can take the sum of the array A from I to j, right? And we can keep a variable answer or result, which will basically keep the maximum sum. So we'll just take the maximum of the sum of I to j and the answer that is already already we have the answer, right? And ultimately you can return answer. So this will be the pseudocode for this. Now as you can see, there are two for loops. So and inside that we have to also calculate the sum of a from I to j. This will also take one iteration, right? Because we have to iterate from the ith index to jth index, and we have to continuously add the elements. So overall the time complexity of this algorithm will be O of n cube, right? And as you know that n is 10 to the power 6, right? So we have to at least do this problem in O of n, or O of n log n is, I think, will also pass, right? So O of n cube will not be okay, because O of n cube will be O of 10 power 18, right? So we have to reduce the time complexity. Now how can we reduce the time complexity? So if we go with this approach only, but if we can somehow reduce this calculation of sum from order of n to order of 1, then we can do this, right? So what we can do is, we can keep another array which will keep the sum of the elements from starting to that point. For example, here uh, the sum from 0 to 0th index will be -2, right? Then the sum from 0 to 1 will be -1. Then this sum will be -1 -3 will be -4. Then it will be 0. Then it will be -1. Then it will be +1, right? For -1 plus 2 will be +1. 1 plus 1 will be 2. 2 minus 5 will be -3. And -3 plus 4 will be 1, right? So this array S, so we can say that S of I contains the sum from 0 to ith index, right? Now if we have to calculate a sum of a subarray, for example from here to here, right? So what we can do is, we can get the sum from starting from 0th index to this index from the above S array, right? What will be that sum? That sum will be 2, right? Because this index is at 0 1 2 3 4 5 6 index. So 0 1 2 3 4 5 6 index is 2, so the sum is 2 from starting to this point, right? And also we'll get the sum till this index from the starting from this S array, right? This index is 0 1 and 2, so 0 1 and 2, this sum is -4, right? Now if we can subtract the sum of this red subarray, the sum of this yellow subarray from the sum of this red subarray, then we will get the sum of this green subarray, right? So here as you can see, this, if this yellow is S1, this green one, the sum of this green one is, let's say, S2, and the sum of this red one is, let's say, S, right? So we can clearly see that S will be equal to S1 plus S2, and we need is S2. S2 is the subarray, sum of the green subarray. So we can calculate S2 is equal to S minus S1, right? And both S and S1 are sum of the subarray which is starting from 0, right? So this operation will take order of 1 time, right? So what we can do is, for calculating this sum, like we can calculate this sum in order of 1 time if we keep another array of sum, right? So that solution will be order of n square, because right previously it was order of n cube, because this function was order of n, but now this is order of 1. So it will be, because two nested for loops, it is order of n square. But still order of n square will not pass all the test cases. For big test cases where the n value is big, it will give a time limit exceeded result. So we have to reduce this time complexity furthermore, right? For this, what we can do, let's see. So let's say there is an array. Okay, let's just take an hypothetical array, right? And we have some sum of this array starting from some index, some random index. Let's just assume that, let's say from this ith index we know the sum of this part, okay, this subarray part, and the sum is s1, right? And after that there is an element here. This is a single element. Let's say that single element is x. Okay, so this is a subarray which may have one or more than one elements. The sum is s1. This is a single element x, right? So if we have this, right, if we have s1, then starting from ith index we can so like what we have to make a decision is whether we can add this element with the subarray or not, right? Because if we can add this element with this subarray, then we will form a bigger subarray from starting from this to this if we add x, right? So this subarray will have a sum of s1 plus x, right? So now let's say x is positive, right? If x is positive, then definitely s1 plus x will be greater than s1, right? So we can basically increase the sum by adding this element x with this subarray, with this green subarray, and we can take this yellow subarray, this part, as the new subarray which has the maximum sum, correct? So starting from ith index, we can say that if we start from ith index, then this subarray will have a lesser sum value than this subarray, right? And we have to find the maximum sum. So this will be the case if x is greater than 0. But what if x is less than 0? What will happen in that case? If x is less than 0 means x is negative. What will be the value of s1 plus x? s1 plus x can be less than 0. Also it can be greater than 0. When it will be less than 0? If the modulus value of x is greater than s1, then it will be less than 0. Else it will be greater than or equal to 0. So what does that mean is, let's say s1 is, let's say 7, right? And x is, let's say minus 9, right? So if you add this, so what will be the value? Minus 2 is 1 plus x. But if x is, let's say, minus 1, so what will be the value? Minus 6, right? Sorry, it will be plus 6. So this will be a positive value. But anyhow, the sum of this subarray, this yellow subarray, right? The sum of this subarray is less than the sum of this green subarray if we add x here. But there is something more to it, which is, let's say there is, like, after x there is another subarray we can take. Let's say we are taking this subarray, right? Let's just assume this is a random subarray and the sum value here is s2, right? So now if we take let's just take this whole subarray. If we consider this whole subarray, if we consider this whole subarray, right, starting from ith index, so what will be the sum? The sum will be s1 plus x plus s2, right? So now there is a possibility that s2 is positive, and it is like much more positive than the value of x. For example, s1 is, let's say, 7, right? X is minus 2, so it will decrease the sum definitely. But let's say s2 is 9, right? So adding this is x and s2, what we will get? We will get 7. So we are eventually adding 7 with s1, correct? And we will get 14, which is a bigger sum, right? So starting from this ith index, if we want to form a subarray which has the highest sum that we can take, if we want to construct that, then we can say that if s1 plus x is greater than or equal to 0, then there is still a chance of getting the highest sum, because there can be an s2 subarray after x which will which has a sum positive and will increase the sum, right? But what if s1 plus x is less than 0? It is negative, right? So at this point we have a negative sum value, right? And if even if we add this value to s2, it will decrease the value of s2 anyway, right? So here let's say this this is not -2, this is, let's say, -21, right? X is -21. So what will be the sum of these two? This sum of these two will be -14, right? And if we add this with s2, which is 9, then it will be -5, right? So there is no point in adding this negative value with s2. It will anyway decrease the value of s2, right? So we can simply take, like, instead of starting from I, we can start from this index and we can calculate s2. We don't have to add this array, this subarray from I to this x, right? So as we can see that from starting from I, if we have to calculate the subarray which has the maximum sum, we can keep going, right? And how we'll keep going? So if the current subarray from I, we have the sum of it. If the next element is positive, then obviously keep going. If the next element is negative and adding that element with the already calculated sum is greater than equal to 0, then keep adding it, because there is a possibility of positive numbers after x that will increase the whole whole sum of the subarray. But if it is less than 0, then there is no point in keep going, because we can start from that index with having a sum 0 and we can continue with the next subarray, you know. So that way we can go the array once and we will get the sum till of each point, right? The maximum subarray that we can find, the maximum sum subarray that we can find ending at each index. And if we can get the maximum out of it, the maximum of all the indexes, then we will get the maximum sum subarray. So what we will do is, let's say this is the array, right? We'll start from 0th index and we will keep going and we will calculate the sum, right? Let's say the sum is s1. Now for next element, if the value is x, we'll see if x is positive, we'll add and we'll keep move on. If this is negative and s1 plus x is greater than 0, then same, we'll add and we'll move on. But if it becomes less than 0, then we will stop here and we will start s equal to 0 again from this index, and then we will keep going again, right? And again when we will get a negative value, we will start this from 0 here and we'll keep moving. So this way, at any index I, what we will have is the maximum subarray ending at I that will have the maximum sum, right? So this array, so let's say this array is, we can call it what do you can call it? You can call it, let's say, s1, right? Or no, not s1. Let's call this array as subarray sum, okay, subsum, let's say, right? So subsum of I will indicate that it will contain the value, the maximum sum value of a subarray which is ending at I, right? So if we will get all the maximum sums ending at a particular index, right? Now what we will do is we will just get the maximum out of all of it, and we can return the answer. So this approach will take order of n time because we are iterating the array once, and the space complexity will also be order of n because we are storing the sum in, you know, in one extra subarray or one extra array. So the space complexity will also be order of n. Also, this algorithm is a very famous algorithm. This is known as Rns algorithm. Okay, this is the name of this algorithm. So let's just code it, and let's I think that will make you understand the algorithm better. Okay, so what we'll have is, let's just take the size of the array first, and we'll have sum of size n, and we'll have a variable s which is 0. We'll initialize it with 0. We'll go through the array, right? So what will be the value of s of I, subsum of I? It will be s plus a of I, and we'll update s with subsum of I, which will be used in the next iteration. So basically s contains the sum till till the previous index, right? At the beginning, the previous index, because there is no previous index, so we are taking s as 0 here. Now if at this point s is less than 0, it means that the ith element, which is x, right, in the one node that I have shown, so the ith element is x, this ai is x, and adding this is resulting to a negative sum. So what we can do is, we'll end here, means we'll again put s equal to 0, and we'll again start from there, from the I plus 1th index, right? And let's just take another variable max sum, which will basically contain the answer. So for each index, we'll update this max sum with the maximum value, that if the s value is maximum, right, and we'll get the maximum value, we can return the maximum value directly here. Let's just test this code. Submit it. Okay, so for -5, okay, so if there is only negative element, then my answer will be 0 because I'm taking s as 0. Okay, okay, so I have to do this before putting s as 0, and also because the minimum value can be -1000, right? So let's just take the maximum sub as int min. Now let's submit. So because previously this maximum was below this if condition, because of which s was overwritten to 0 when s was negative, but we don't want that, right? We want s to be the value at the ith index, the exact value, even if it's negative. So that's why I moved it here, right? So this got accepted. I hope you understand the solution, considering that this is my first video, so I'm not sure that whether I'm able to deliver it properly or not. Please give your suggestions in the comment section. Thank you.